through what we did on the last session. So we're trying to see how do we do a backup. That is, when we do a stash, practically, we'll take a backup of the changes as well as we will be undoing it before we have committed. The same thing, when you have done some changes and before you're going to do the commit, if you want to undo the changes, then you will be using git reset. And in that, with respect to which area in your workspace you want to undo, we were using the reset, soft mode, mixed mode, or hard mode. And in that, finally, we were checking at if I have done a commit already, and then those changes will be permanently stored in the repository. So if you want to undo a commit, then you will be doing a git revert that commit ID, where for this revert, it will once again create a new commit ID for a reference, whereas the changes will be taken back to the original commit ID. So this is what we had seen in the last session. But now let's go ahead and work on a scenario where now when you're working on Git, always we will be working on the latest commit ID, so that we will create a workspace, and then in that workspace we will do some changes, and on top of that we will be going to a particular workspace, and inside that the latest changes is what we will be working. And anything you want to do, again on top of that, you will be doing some changes, create a new commit ID. So that way all those changes that whatever we are going to do will be on the new commit ID or the latest commit ID. Okay, but for some reason, if you want to go back to any other commit ID, how is that you will be going? For example, now let's say this is my workspace and these are the commit IDs that I have. Now a scenario, what happens is when you want to do a revert, let's say that QA is trying to test a change and they figure out that your change is causing problem. And that way, now if they ask you to revert, or if they are trying to revert, you would like to test the same changes again and see whether there's a problem or not. So that way, now you might have done some change, and as of now the changes that is available in the central repository could be something on top of that, and there are many changes that has been created on top of your change. So now if you want to go back exactly to a change which you have done, then there would be a requirement where the latest commit ID is not the one that you're interested to work, but to traverse or to go to any other commit ID which is available in your repository or the central repository. So that way, when you want to switch between one commit ID to other commit ID, then you will be using the command git checkout and the commit ID. Okay, so once again, the requirement is whenever you want to switch between one commit ID to older commit ID, then you will be using this. So basically my interest is from the current commit ID wherever we are working, we would be interested to go to a particular commit ID and work or look at the changes what we have there. So ideally what happens now here is when we are working currently, this is the commit ID where we are working, and this is being referred to the head of the branch. Now suppose if I switch from my current commit ID to a specific commit ID, let's say I am moving to this commit ID, then the head of the branch will be removed from here, and particularly this will become the head of the branch. Okay, so that is how when you choose which commit ID that you want, practically that will be the head of the branch on which you will be working. So that is when on the last session when I was explaining, I said head of the branch is that particular commit ID on which we are working. So that way by default it is always the head of the branch, but if you want, you can choose which commit ID that you want to work. And how do you choose? Basically we will be moving the head of the branch from the latest to whatever commit ID. So that way now, for example, if I want to go back to this particular commit ID, then I will use git checkout and specify this commit ID. So then the head reference of the branch will be moved from here to here, so that when you look at the workspace, you will be actually working on this commit ID and not on the latest commit ID. Okay, so that is how we will be moving. So getting it, and what do we mean by moving from one commit ID to other commit ID, and how exactly it moves? It is not just moving, but internally the head reference will be moving, and with respect to that, the changes will also be visible only in that way. Now, here, if you go back, now in the 3.java, actually we added a line called as dummy line, and then we try to revert. That is what we did from the previous command by practicing. So first what we did is, if you recall, I created a new commit, and then in that commit, actually I added a line called dummy in 3.java. Okay, and then for practicing the revert, what we saw was we tried to revert this particular commit ID, because of which the content what you had earlier was this, that is in the 3.java only 2 lines were there. So the revert created a new commit ID and we came here. So this is what we did in the last session, if you can recall. So now what I'm saying is, for example, if someone is telling you there's a problem and you would like to go back to a particular commit ID and see whether the changes what you have is exactly causing the problem. That is, you want to get back the same changes. So that is when now I don't want to work on this commit ID, but I would like to go back to this commit ID and just see some changes. Okay, so that is when, if we have to switch from one commit ID to other commit ID and work, we will be saying git checkout, and then we will be using the particular commit ID. And now if I say git checkout and the commit ID, if you can see it very carefully, the output of the git log will be differing. So right now it is showing everything with this reference, because this is where the head reference is pointing. Okay, and now when I switch, now what did it do? We have taken the head reference from here and we are telling to the Git that I am not interested to work on this. I am interested to look at this particular commit. So that is why the head reference would have been moved to this. And because of that, whatever the content or the files that we had exactly in this commit ID, you will be seeing it here. You can see, as well as if you see a Git log, you can now see that the Git log will be giving only the list of commit IDs from the current commit ID where we are pointing, not everything which is available in the repository. Because when I say Git log, it will always take the reference of where the current head reference is, and from there it is going to point everything. Okay, so you can see here, earlier the head reference was here by default, that is the latest commit ID. So the git log was able to give us everything. But now when we moved the head reference using the git checkout command, we are pointing to this commit ID, and because of that, whatever contents we have, we are referring. And not only that, if you can look, the git log is showing only from this commit ID and all the details below it. It is not showing anything above, because it always assumes that this is the commit ID that you want to work, and with respect to this, git log will always show everything from the current commit ID or the current reference to the oldest commit ID. Okay, so this is what we do by switching the commit ID's reference from one place to other place, so that now I have all those things that is needed. I can go ahead and do the testing. If everything is fine, then if I want to change this, or in case if I want to refer, I can have a look. So that is how we will be switching between one commit ID to other commit ID, where By default, we will always be referring to the latest commit ID, but if needed, I can go back to any commit ID that I want by using git checkout, and I will specify the exact commit ID. Okay. But if you look at it here, we have used the git checkout command sometime back in some other scenarios also, right? Can someone tell me that where we have used the git checkout command?
For check-in and check-out, the
No, I didn't get it. Yeah, I'm saying where did we use this checkout command earlier?
For switching the branch.
To use different branch.
Exactly. So if you recall, we used checkout command to switch between branches, right? Now I'm using the same thing to switch between commit IDs. So what exactly is happening? Now, if I say git checkout, basically I'm switching between the branch in this workspace. Now here, let's say I have these two branches. Now, if I want to go back to this particular branch, if I say git checkout test branch, it is going to take me to the test branch. Same thing, if I say git checkout master, it is going to take me to the master branch. Now, if I say git checkout a branch name, it is taking me to a branch. But if I say git checkout a commit ID, then it is taking me to the specific commit ID. So how exactly Git is working? Okay. Okay, so see, this is the scenario. If you recall, why do we need to undo a change? So if you can recall the scenario, if you have done a commit, why is it you want to revert? Let's say that when you have submitted a change, okay? Now let me put it up this way. Now consider this. Now in Git, we know that we will be having one central workspace, okay? And in the central workspace, we will be storing everything. And from this, we will be having a local workspace. Like this, many users will have their local workspace, okay? So first what you will do is, you will create a change in your repository, or you will do the commit in your repository. Like this, everyone will be doing the commit in their workspace. And once that is done, you will be pushing it to the central repository. So like this, everyone will be pushing their changes to the central repository. Here, you will be storing everything. So now with respect to this, you will be having, suppose if you want to again continue working, you want to take the latest changes, then you will update your workspace with the latest changes. That is what we call it as pull, in which your workspace will be updated with all the changes that you had in the central repository, and you will be continuing doing the changes. Okay, so in that way, now these two changes is what we did earlier in this workspace. Okay, now assume that first you did these two changes and then you push to the central workspace, and after that from this workspace a user submitted other two changes. Now you have added all those things back to your workspace and you are trying to do some other change. Now if let's say we are taking all these changes integrated and giving it to the QA for testing, and while testing they find out that your change is causing a problem, and they are telling you that, hey, there is a problem with your change, and I see that because of your change there is a functionality failing. So if they say, and if they want you to revert your commit ID because they suspect that it is a problem from your commit ID. So when you are given a scenario that you want to undo or you want to revert your commit ID, you are not just blindly and going to remove this. First, you want to verify whether that is a problem or not. So in that case, right now, you are not working on the latest commit. I mean, you are not working on your commit ID. You are actually working on a latest commit ID, which has been updated from the central workspace. So this scenario, you want to go back to your commit ID and just do the testing once again, or you want to have a look at everything so that whatever is failing for the QA, you want to retest it in your place with the same commit ID and take a reference. So that is how, in this scenario, instead of looking at the latest commit, you want to go back exactly to your commit and see whether the changes or the actual problem that is happening is because of your commit ID. So like this, at any point of time, if you want to go back to a previous commit ID, that is, you want to traverse back to a previous commit ID, then you will be using the git checkout under older commit ID name. Getting it? On when you will be requiring to go back to a commit?
Yes, sir.
Okay.
Yes, sir.
So in that scenario, now what I'm saying is, earlier, now when we were working, this was the latest commit ID, but now there is a requirement to come here. Okay, so we have come here, and with respect to this, the git log is showing only the commit IDs from here to below, because the git log command works in the concept of showing all the commit ID from the latest to the oldest timestamp with respect to where the head reference is pointing. So that is how currently the head reference has been moved here. So we are trying to see everything from this place to below this. Now, what I was trying to ask the question is, we use the same command to switch between branches, as well as we are using the same command to switch between the commit IDs also. So how does the Git know that this is a branch and this is a commit ID? So that is something very important that we need to understand. So now if you try to understand in Git what exactly is happening. Now let me take. So now if you say you are working in a Git, first of all, you have to tell in which repository you are working. So that depends on your workspace. So first, which workspace you are working, and in that workspace, first you will tell which repository you are working, right? So every workspace, now we know that we will be having a repository. So that way we will be saying that this is the working directory, and this is the staging area, and then you will say the repository. So this way, now inside the repository, are we storing everything directly? No. Actually, within the repository, now we know that there is something called as branch, and only on that branch we are trying to store all the changes. So in our case, we had a branch called master, which is the default one, and we also had a branch called test branch. So that is how now we know whatever that you're going to store is not on a repository directly, but inside a repository there is a particular branch, and in that you are trying to store something as a commit ID. Correct? So this is what now we have. Now if you look at this, it is something where if you want to refer to a commit ID, you are not going to refer directly to the commit ID. So this is something like where we have to tell which repository you are working, in that which branch you are working, in that which commit ID that you want to work. So that way, if you want to refer to something in a Git specifically, you have to tell what is the branch name, and with respect to that, what is the commit ID that you are trying to work. Okay, so simply in that way, now we are already inside a repository. So now I know anything that I'm doing is this within this repository. So specifically, if I tell to a commit ID is not directly referred, because you will always refer with respect to a branch, and in that branch which commit ID. Now to understand this, let's practically go back. Let's say that when you are trying to study, or pretty much if you are still studying, now from outside, if someone asks you, hey, what is that you are doing? You will simply say, I'm a student of this technology or of this class, correct? But particularly if you're going into the college and if someone says, you cannot say the same thing. Now you have to tell specifically that you are studying in a particular section or a department, and in that there is a particular registration ID or a number given for you using which people will identify you, or a roll number, correct? So in the same way, now I ultimately whatever that we are referring to Git, everything is a commit, but we cannot just say a commit, because a commit is specifically attached to a branch. So that is how whenever we are referring to something, it is actually a combination of both a branch on which you are working and then a commit in which we are referring. So that is how you are actually going to work on a particular commit ID attached to a branch. Okay, I cannot say, hey, are you working on a branch? No. What do you mean by working on a branch? On that branch, what commit ID exactly you are working? So that is what we will have to refer going forward. So in that way, now whenever you are referring something, actually Git takes these two format. That is, what branch you are working, in that what's particular commit ID that you are working. Okay, so when you have such a scenario, how did exactly it work in these two ways of giving? So when we are checking out, or when I say checkout, we are interested to switch from one particular reference to other reference, where every time when I'm trying to check out, I am interested to go to a particular commit where I have to tell both the things. So that is when, until now, when we are switching from one branch to other branch, what happened? So if you have noted, when I'm saying that I am switching from one branch to other branch, did we go to a branch, or in a particular branch, did we go to a particular commit ID? So if I did a git checkout from one branch to other branch, it was actually taking us to the branch. And in that, where did we actually pointing? We were always pointing to the latest commit ID of that branch, right? So that is because when you try to do a git checkout, you need to give both a branch and commit. Whereas when you just give only the branch name, then what it will do is, by default, it will take you to the latest commit ID. Okay, so this is the default on how it used to work. So that is why when I did the git checkout a branch name, for us, what we thought is we are just switching the branch, but internally Git was not just switching the branch, but it was trying to take us exactly to the latest commit ID in the branch. So that is how, as soon as we switched the branch, we were able to do the changes on top of the latest commit ID, and we were creating new commit IDs. Okay, so remember, when we did the git checkout branch, it was not just a branch. Internally, it took the latest commit ID as the default one. Okay, so in that way, now when I did a git checkout commit ID, even for this, there is a branch needed, because when I say commit ID, which is that commit ID and where is that commit ID? That is also important that Git should be knowing. So in that way, when you do not pass a branch name, and if you say only the Git commit, then what it will do is it will take the current branch on which you are working as the branch in which the commit ID has to be referred. So it will take that, okay, within the same branch, you are interested to go to one more commit ID. So that is how, if you are working in one commit ID, and if you say another commit ID, it will basically take the current branch as the default branch, and it will be trying to move from that commit ID to current branch, another commit ID. Okay, so that is how whatever that we switch, exactly the head reference will be helping us to point the content of it. Okay, so going forward, now since we know that whatever we are storing is particular to a repository, and in that repository specific branch, and in that branch we are actually working on a particular commit ID. Okay, now why did I explain this? The reason is, if you come back, you can see currently this is not the latest commit ID on which we are working, isn't it? Why? Because earlier we had the latest commit ID as this, but by doing a git checkout of this commit ID, we just came from this location, or we moved the head reference from here to here, and we are trying to look at this because I had a requirement to see whether there is some problem with this changes reported by the QA or by someone else. Okay, so that is why I tried to move. Now, as of now, you can see that it is not showing this latest commit ID. Okay, in some scenario, let's say if you don't remember this commit ID at all. Let's say I deleted it now, and here also you deleted it. Deleted in the sense I'm just saying clearing the screen. Now, if you want to go back to the latest commit ID, how will you go back? So if I want to go back specifically to the commit ID, if I had known the commit ID, I can say once again git checkout and the latest commit ID and I can go. But if not, can someone tell me if I want to go back to the latest commit ID, how will I go? Right now I'm pointing to this, and what I'm asking is, how will I go back to the latest commit ID in this branch?
That
You
is
have the
only
answer.
latest one, right?
Sorry, come again?
That is the latest one, right?
No,
Okay,
this
Adam,
is not
you
the.
say can we use, like, you say we cannot use the git checkout and commit ID. Can we do that?
Yeah, we can do, but as I said, I don't remember this. So if you see, I just removed it. So I don't have a reference on what was the commit ID. As of now, if you are clear that there was a commit ID before this, and I tried to check out from that location to this location, that is how the head reference came here, right? So if I know this commit ID, as you mentioned, I can give it. Basically started with, this is what the commit ID that we have, but I'm just trying to say, think that you don't copy, I mean, you didn't copy paste. So now what will happen? You neither
Git
will
log
get the output here,
online.
even this will not show. Why? Because the head reference will always show where you are working, and from there everything it will be showing below. But how is that I can get back that?
Is
Is
use
it
the
Switch
revert?
like
branch by revert.
Is it
Sorry,
revert?
Yeah,
using the
switch
index
branch and
number.
come back to this branch again.
I hear a couple of answers, but did someone say git checkout and what was that?
Yeah, git checkout to other branch and come back to this branch again to check out this
Exactly,
branch.
that's the right answer. Now, I gave you the answer here, right? So, what will happen if I say git and a branch name, git checkout and a branch name? For example, if I just say git checkout test, what does it mean? Just now I explained. When I say git checkout test, what is git going to do? It is going to switch from your current branch to the test branch, and in the test branch, where is that you should be working? By default, it will always take you to the latest. So that way, it is going to take you to the latest commit ID of the test branch. Same thing, now I am currently working in the master. So if I want to go to the latest commit ID of master, what is that I have to do? Simply if I say git checkout master, what it will do? It will take me to the latest commit ID. So my problem is solved. Whatever the requirement that I'm saying now, regardless of what is the latest commit ID, if I once again simply do git checkout master, you are not just switching the branch, but you are going back to the latest commit ID on the branch, because anything that you refer going forward is specifically a branch and a commit ID attached to it. That is how you switch between one commit ID or a branch in it, because I'm not interested just to go to a branch. In that branch, what particular commit ID I am interested to work is what we are switching. Getting it? So now if you look at this, this is what I have. And again, the answer what you said is exactly correct. I don't have to switch again to test and come back. Simply if I run the same command git checkout master currently, it will just refresh. It is like you are currently pointing here, and if you do a git checkout master, once again it is going to refresh and it will come back and refer to the latest commit ID. Okay, so now you can see the latest commit ID that you're pointing is the new one, because the checkout command has taken you from the current commit ID wherever that you're referring back to the latest commit ID which has been available on this workspace. Okay, that is how when you do a checkout, it moves the head reference from one location to other location with respect to what you have given. When you don't give a commit ID, it will always take you to the latest commit ID, and with respect to that, you can see everything will be changing. So that's when, in our example, when I did a git checkout of the branch, it is once again going to take us to the latest. Okay, so that's how the head reference has been taken here, and it is applied back to the new or the latest commit ID on this way. Getting it? What do you exactly mean by a checkout now, and how you will be switching from one commit ID to other commit ID? In fact, when I say git checkout branch, even in that, you're not switching between the branch, but we are switching in a particular branch, a particular commit ID to another commit ID. Getting it? On how Git exactly works and how you will be able to see a particular commit in Git?
Yes, sir.
Yes, Adam.
Again, don't get confused, because that is what I'm trying to stress the point here. If you say revert, you are trying to undo a change which you have done. I am not interested in undoing. In this scenario, I am just interested to switch from one location to another location. If I'm working on the latest commit ID, if I just want to go back to the previous commit ID, that is traversing, you will be using the git checkout. Okay, revert means I am not interested to keep that commit ID anymore. I want to remove that change from the workspace. Here, I'm not trying to remove. I'm just trying to switch from the current location to some other commit ID to see the content what I had done at that point of time. So for that, I'll be using git checkout. Okay. So everything looks the same, but internally you are changing many things. So here you are trying to undo a commit itself. In this, I'm not touching anything in the repository. It is going to be the same, but the only thing is, instead of referring to the latest commit ID, I am saying to go back to a particular commit ID and change, or just to look at what changes you have done there, we are seeing it. So that is what we do using git checkout. All right. Now, is that clear?
Yes, Adam, it's clear.
Yes, it is.
Okay. So now, when you're trying to do some changes, let's say in a particular release, you are no more interested to work on a particular feature, or let's say that you decide that a particular functionality should not be available in your product from a particular version. So that way, a particular functionality is going to be obtained from a file in which you have written some code, right? So that way, if you want to delete a file because of which you will not be allowing any particular functionality in a product when you release, so you don't want users to be using this file anywhere going forward. So that way, if you want to delete, we are not just going to delete the file directly, because if you delete a file, we now know that you are deleting only from the working directory. So deleting a file should also mean that you are trying to store it as a commit ID, so that if anyone is trying to refer to this latest commit ID and work, then they should not be able to see the file. So that is how, when we are deleting, we will be using git rm and a file name. And what that will do is it will try to delete the file from your working directory, as well as it will put into the staging area. So now you have to go ahead and do a commit. So this way, you don't just delete the file from your working directory, but you store it as a reference inside the repository. And now, if you push this to the central repository, anyone who is trying to take that latest commit ID or creating a clone of the workspace from there, he will not be seeing that file going forward. And whenever they want, if they want to refer, they can come back to this particular commit ID by doing a git checkout. But if not, as a developer will be working only on the latest commit ID, where he will check out a latest commit ID and he will try to work only on that, and he will be doing commits on top of that. So that is how, when you want to delete something, you just delete the file and put a commit ID for that also, so that you keep it as a reference, and going forward you will not be able to see the content. But at any point of time, if you want to take the reference of this and go back to a commit ID where it was available, so that way you can traverse whenever is needed. If not, on all the going forward latest commit IDs, you will be not able to see the file. Okay, so that's how you will be using git rm to delete the file as well as go ahead and do the commit. Okay, so it is not just deleting the file from the working directory, because deleting a file physically is only from the working directory, and we have to make sure the changes is available in the repository also. Okay, fine. Now, if you recall, in the workspace, now if you have certain files which is created during runtime and you do not want Git to track that, then what is that we did?
Git ignore, we used it.
Exactly. So what we did is we created a file called .gitignore, and in that, any file that I put, basically it used to not consider that file at all. Okay. Now, this is one of the good practice wherein, let's say if you are working on a project and in reality you will be having thousands of source code that will be available in your workspace for that project. Now assume that this workspace is for a project on which I'm working and I have 10,000 actual files. Now if I do a test by compiling it, actually I'll be getting many runtime files and many different kind of output files. And as a developer or as a QA person, it will not be easy to keep on adding every file that you get. Maybe here I have directly told only to reject class files and the log files. But when you're trying to work, basically you're not considering these files for the Git operation, but everything is going to be available in your workspace. So that is when, ideally, when a developer is trying to do the change, he doesn't want any of the previous output files, and he wants to delete all the previous output files, and then he wants to create everything freshly. So this word, calling it as clean, means you want to clean your workspace with respect to all the untracked files that is available. So that is how, especially when a developer or we as a product, when we are trying to create in this workspace, when I don't want to have any of the previous output files or the runtime files, then we would like to clean our workspace in such a way that all the runtime files or the output files will be deleted. Okay, so then if you want, you can try to retest or rebuild everything in your workspace. So this is one of the requirement which the developers will be having, or whenever we are trying to build a product, we would try to delete all the previously created files, that is the output files, and generate all the new files with respect to what is the modified file. So that way, now if you want to delete all the untracked file from your workspace, then you will be using a command called git clean. Srijan, can you come mute,
Oh,
please?
sorry.
No problem. So that is when from your workspace, you are not just interested to remove, tell to Git to not consider, but practically my interest is to remove all the files from the workspace. So that way, now let's say you create some XLS files. Okay. XLS is nothing but your Excel sheet, or you create some documents or some output files. Okay. So now here, if you run git status, you will be getting all this untracked files. So if you want to delete all of them, simply take the command git clean, and first you run a option called -n, where -n will show you a dry run of what are the possible files that it will be deleting. Okay, so that way it is saying in your workspace there are two untracked files, and these are the possible ones that we can delete it. So if you want to delete all the untracked files from your workspace, simply say git clean with the -f option, where you are going to forcibly delete all the untracked files. So you can see you have not done anything to your actual file which has been committed into the repository. So only those untracked files that you have generated for the output of doing a testing or creating a product. So those kind of runtime files or output files that you have created and that you have not stored into the repository is what we call it as untracked, and everything will be deleted. Okay, so this is something as a developer or when we are trying to create a product, we will be using this. Pretty much we'll talk in deep about clean in the next module called build management, in which how is that we are going to convert these source code into a file from which we can create a product. Okay, but as a user, if I'm not interested to keep all the runtime files in my workspace, and if I want to recreate it, basically I want to delete everything. So that's when you can use git clean, which will remove all the untracked files from your workspace. Okay. Okay. Now, moving on to the next topic. So in Git, we have something called as tags. Okay. So we can call it as a tag, or sometimes we also call it as label. Okay. So what exactly come to your mind when you say a tag or a label? Don't just think only from the Git or somewhere related to it. In a general term, what do you understand by the word called tag or label? Have you used it anywhere in your day-to-day life? And again, have you come across such a word called tag or label anywhere?
Yeah, it shows what exactly is a particular item.
Like, where did you use?
The tag is
For
used on the luggage, for example.
Okay, that's exactly right. And anywhere you go,
kitchen, we use labels.
yes, you go to a shop or you try to, travel everywhere. What is the purpose of the tag? Tag means it will help us to point to a particular reference, right? You have something, quickly you want to identify, you use the tag to identify your luggage or you identify a product, and you will be getting the details about it, isn't it? So that way, now, why is tags used in our Git or in the version controlling system? Now, when you are actually working on Git, it's all about creating commit IDs. I mean, other than the user, if you're looking from the maintenance perspective, what is that we are doing in Git? We are trying to store and maintain and track the commit IDs, correct? That is what ultimately the endpoint is. But when you are using this commit, day-to-day basis, you will be doing commit on top of commit and everything will be stored. And whenever we want, we will be taking a particular commit, create a product and verify the tests and everything is fine, we will be giving it to the customer as a release. So at any point of time, if you want to baseline or identify what is the commit that we have used specifically for a release or specifically for a QA to test, it is not easy for us to remember, because no matter what commit ID or a commit message you give, it is not easy for us to identify quickly whether this is the commit ID that I have used for a release or this is the commit ID which QA has tested for a release. So in that case, if you want to quickly identify, you can use the concept of tag here, where a tag is nothing but a simple name or a string which you can use a naming convention of your wish, and basically you will attach this string or the name to a particular commit ID. So that is how you can refer to a commit ID using a tag. So going forward, if you say a particular tag, internally it will be pointing you to the commit ID which it is attached. So like this, you can create a name and attach it to all the commit IDs so that whenever you want, you can quickly refer to it. So rather than remembering the commit ID, which is obviously various characters that you can see, different numbers, it is easy for us to remember a name. And when I say a name, every organization will follow a particular naming convention so that it will be easy for them to remember. Now, assume that if we are trying to use a tag for release purpose, okay, then I can use a naming convention, say the word should be beginning with REL, and then you will use some version number. Okay, now let's say this is the naming convention I'm using, and if I want to release a product for version 2.1, then I'll say release 2.1. If I want to release it for 2.2, then I'll say 2.2. So if you see, it is quite easy for me to keep a track of everything. And suddenly if I say, hey, can you tell me what is the release tag name that you have used for releasing 1.2 version? This is how it will look, correct? So you will be following a naming convention, and now you don't even have to remember every name. So if you just remember the pattern that you are following or a naming convention you are following, it is easy for us to recreate any particular tag name by this naming convention, and we can refer to that. So like this, you will create a name or a string, and then you will attach it to a particular commit ID. Okay, so that now any point of time, if you refer to this particular tag name, it will directly take us to the commit ID to which it is attached. So that is how it will be easy for us to refer to a commit ID with respect to the tag. So you can use a tag to identify a release, or you can identify a particular build that you have given to the QA for testing. So for whatever activity that you have done, you can baseline or you can benchmark it using this name, so that quickly we can use this to refer a particular commit ID. Okay, so how is that you're going to create a tag? So to create a tag, you will be saying git tag, that is the option. For that, you will say the pattern that you want to create, that is the name, whatever that you have created. This you will be putting it using the -a option. And then once again, for creating a tag, you should say what is the message or what is the purpose you are creating this tag, so that later when you refer, you will be knowing it. And then to what commit ID you want to attach this. Okay, so all those things will be given together. So now let's say you want to apply this to a particular commit. Now let's say that I choose one particular commit ID where I have released for some purpose. Now let's say I have taken this. Now if I want I can apply a tag to this. Now here, this is the commit ID, and for this commit ID, let's say that you are going to apply a tag name. So I can take a particular tag and I can apply to this. So now if I want to apply, what I'll say git tag -a, the name of your tag that you want to create and apply. So that is what you will say it here. And then the message, I'll say release tag for version 2.1. And then what is the commit ID to which you want to attach this? So you can see that you are attaching it. And at any point of time, you want to see the list of tags available in your workspace, you can use git tag without any option, it will show you. And now if you say git show and this tag, if you can look at, it will say that what is the date and timestamp on which it was created, as well as which commit ID that it is referring to. So that is how, by looking at this tag, it will show us the complete details about this particular commit ID. You can see that this is the person and this is the timestamp on the message on why it was created. And in that, if you look, it is internally pointing to this commit ID. So this is how it is equivalent to directly saying git show of this. So wherein I don't have to remember this name now. So if I just remember this with respect to this, I can always get back which is the commit ID that we are referring it to. Getting it? Now,
Yes, sir.
here, when you are creating a tag and applying, now for the same commit ID, I can create another tag and apply. Because let's say I did one more release and that release also is on the same commit ID for a different user. So like this, for a given commit ID, I can apply more than one tag. That is possible. Okay. Now, let's say I want to create another tag and apply for the same commit ID. Because both of them are going to point to the same commit ID. But I cannot apply the same tag to another commit ID, which means now okay, let me just scroll up quickly. This will take a long time. Now let's say I want to apply the same tag to some other commit ID, then it will not be allowing me. Let's say I am taking the same tag and applying to another commit ID, it will not allow. That is because a commit ID can have more than one tag, but one tag cannot be applied to many commit IDs, which means a tag is associated only to a particular commit. You cannot have the same tag referring to too many commit IDs, whereas one commit ID can be pointing many tags. It's the same example where whatever product that you're going to buy, for example, now someone said luggage. So for the same luggage, I can put a tag which gives me a particular reference details of what is that product or from where to where I'm moving. Let's say that your onward journey tag has been applied. And on the same one, if I want, I can attach one more tag which will give me the details of my return journey or some other details about the product. That can happen wherein for the same material or a product, I can have many references by tag. But I cannot take the same tag at a given point of time and put it to two bags or two luggages, right? So something similar, when you take the commit IDs, on a single commit ID, I can attach many tags I want. But if I take one tag, it should always be attached to only one commit ID. Getting the difference?
Yes, Adam.
Yes, sir.
Okay. So remember this. So a tag is always associated only to one commit, whereas a particular commit can have more than one tags attached to it. So exactly like I said, for a product, you can have many tags attached to it, but a single tag cannot be shared between two products. Same way, a single tag cannot be shared between two commit IDs. If it is attached, then it should be using only this. You cannot use the same name for some other commit also. Okay. So now, if you look, whatever tags that we created, once again, where did we create? Because anything that we create now, it is stored only in that repository where we are working, correct? So that way, if you are creating a tag, you are basically first creating the tag only on your workspace, or it is stored only in your repository. So that is how, if you want to share this to others, you have to push this to the central repository. And for pushing this, so far what we did is git push, where we were pushing the commit IDs. But if you want to push specifically a tag, then you will say git tag, that is, sorry, git push and tags. So now if I say git push and tags, what it is going to do, it is not just going to consider the commit IDs anymore, but instead, if you have any tag in your particular repository which is not available in the central repository, then it is going to push all the tags so that anyone else who wants to work on the product will be getting the reference of this. Okay, so that is how you decide, once again, whether only you want to use it or if you want others to be using it. So if you want to share, then try to push those reference details to the central repository. Okay, so once again, if you want to delete a tag, simply you will say git tag -d and a particular tag name. But here you are not deleting the commit ID, you are just removing the tag. For example, from the same luggage, if you want to tear off a tag, you will be just tearing only the tag. You are not going to tear the luggage or the product. The same concept, you are only deleting the particular tag name, that's it. But whatever the commit ID that it was referring, you will still be having it. So nothing will happen to it. Okay, so you are only removing the reference name or the tag name from that particular commit ID. So that's a difference where you can remove a tag whenever you want and apply it on a new commit ID based on your need. But you cannot apply the same tag for two commit IDs, whereas you remove it from one commit and then apply it to on some other commit ID. Okay, getting it?
Yes.
Yes, sir.
Yeah.
Okay, so pretty much until now, we saw on different kind of scenarios on how you will be doing the changes, how you will be pushing it, how you will undo or traverse or delete a file. You know, pretty much as a user, we were seeing all those things. Going back to one of the initial understanding, what is the difference between a central repository and a local repository? If you recall, a central repository is a repository of the type bare or a bare repository where we cannot do any change. Whereas on your local workspace, you are going to store the changes as well as you can modify. And then in a workspace, I said you are going to have these three areas. Now, where exactly is this three areas? Because if you come to your workspace and you can see that you are only seeing the file. So that means practically you are actually looking at only the working directory, because working directory is the place where you will be seeing the files. Then where exactly is this repository? And staging area, as I said, it is a buffer place which will be stored inside the repository. So now the question comes, where exactly is the repository? Where exactly all the commit IDs has been stored? Because when I run something like git log or git commit, it is trying to store everything. Where exactly it is storing in this workspace? So to understand, if you do a ls-a or ls-al, you can actually see that there is one more folder called as .git, which is hidden. Now, if you go inside this folder, you can see that it basically has a lot of files and contents, where this .git folder is your repository. And this is where it is trying to store everything in terms of your commit IDs or the references, whatever that you are doing. Now, why is it kept separately as a folder? It is because now, if you had all these files on your working directory itself, it will be confusing for you on to differentiate what is your actual content of your repository as well as what is the references that it is storing. So that is how to differentiate between your working directory and the repository, and to make sure that you are not messing up with this file. Because if you mess up with this file, Git is not able to, or it will not be able to get any information from that. So it is just going to be like a normal directory on your operating system. Okay, so that is why it is being kept separately, and the logic is you will be having a folder called .git hidden in your workspace, and inside that you will be storing everything. Okay, so this is how the workspace on which you are working is what we call it as the working directory of your workspace, and inside that you will be having a separate .git folder which will be acting as your repository to store all the commit IDs and branch information inside it. Okay, so that's the basic difference. Now, if you go to your central repository and if you try to look at it, you can see that this is somewhat exactly similar to what you have in a Git, whereas you do not have a working directory in the central repository. That is the reason why we cannot do any changes in the central repository directly, because if you want to do some change, you should be able to see the files. And where will be able to see the file? Only in a working directory. And that is the basic difference, where in your central repository, you do not have a working directory. So all the content of the Git repository is directly available in the central repository. So that is how, if you try to do any operation, it will not be allowing. That is the reason why we say central repository is used only for storing and sharing, whereas the local repository, it has a working directory, because of which we can see the files, you can do the modification, as well as you can store, and storing will be going into the Git directory separately. Okay, so this is the difference between a central repository and a local repository. Getting it?
So yes.
Okay, so now, sorry. So now we practically saw what is the difference between a central repository and a local repository. The only difference is, in a central repository, you do not have a working directory. Hence, the content of the repositories will be directly available inside your workspace. Whereas in the local workspace, I need a directory where I can see the files. So that is how you will be having a working directory. And because of this, all the repository detail will be stored separately as a .git folder. Okay. So now, so far, what is that we did? So we created new workspaces, and then we were trying to store the central repository. But ultimately, when you go back to production, many users will be working on a particular central repository. In that way, the local workspace that you are creating for your day-to-day activity is what you will be having in your machine or in your laptop. But where exactly you are going to keep all the central repository? Now, let's say all the 19 or 20 of us have to work on the central repository. Now, I cannot keep the central repository in my laptop because none of others will be able to access. If so, we have to make sure that it is shareable. So instead of that, I have to keep it in a common location where every one of us should be able to access. So that way, if you want to make a process, especially in DevOps, it is not just about creating it, but it should be in such a way that it should be easy to access from anywhere, and it should be easy to simplify the process of maintenance. So that is how in organization, rather than keeping it in a particular machine, we use one of the area called as GitHub, where GitHub is nothing but an online place where you can store all your projects. Okay, so like GitHub, we have many other tools, but one of the popular places is GitHub, where GitHub is a online place which is available for free to store our repositories into it. So rather than storing the repositories in our local machine, we can create a directory, or we can create a repository in GitHub which is online, and you can store everything there. So if you go to github.com, it is just like creating a Gmail ID specific for you. Okay, so now actually by default I have logged in. If not, what you will have to do is you will have to basically create an account in GitHub using any of your email or a Gmail, and then if you come inside it, you can use this to store repositories. Okay, now you can see I have stored 3 repositories into it. So that is how, if I want to refer to a person saying that, if let's say I am asking you to create a workspace. Now, if I want to allow you to create a workspace from this central.git, which is available in my laptop, you guys should be able to reach my laptop. But instead, let's say the same thing I have uploaded here. Now, I will just give you the reference of how to access this by using this. So here, if you say, this is the reference where you are going to access it. So simply now, from your machine, if you just say git clone and give this, because this is the place where we have the central repository. And since you can see it is ending with .git, this is the central repository naming convention. And now you can go ahead and create your new workspace. So this is how you can use the GitHub as an online place to store your central repositories whenever you want. Now you can clone workspaces with respect to that, and any changes that I do, basically I can do a push or pull that will be going to this particular repository which is available on the internet, that is online through the GitHub. And GitHub by default is free for use. But the problem is, when it is free, it is available for everyone. And if you're trying to put some files as a repository into the GitHub, it is public. Public means if needed, anyone can access. So that is one. With your going as an organization, you can purchase a separate place in the GitHub where it will be private. No one else can be using. But other than that, in terms of the open source project, now you can see that many people who create their product and they want people to use it and they want to store it someplace, they will be storing it in GitHub, and they will be allowing people to access this in terms of this location. So now, if you want to work on this project, all you need is this particular URL to access the central repository. So until now, we were working on our local machine, and in that we had a central repository. So instead of having it, simply now you can keep the workspaces or the repositories online. So GitHub is nothing but a location on the internet or online to store your repositories. It is not another tool. It is just a location to store your repositories. Whereas Git is the only command or the tool which you will be using to work. People might confuse saying that GitHub is another tool. No, GitHub is nothing but a place online where you will be storing everything. Okay, so what I want you guys to do now is, since we have come to the end of Git, pretty much create a new account in GitHub, sign in, and then whatever the workspaces that you have, try to upload to this. Okay, so how to do? Click on new repository and then create a new name for it and start creating a repository, so that rather than creating a bare repository in our machine, we will be trying to create a bare repository directly in the GitHub, so that from here you can do a git pull or a push later on as your need. So that is how, instead of having everything in your laptop, you can create a online place for storing your repository. That's the difference between Git and GitHub. Getting it?
Yes.
Yes, sir.
Okay, so pretty much now, if you go back and try to understand the difference, whatever that we had between Git, because in the very first session, for those who have attended or if you have gone through the video, you would have seen that the major advantage of Git is speed, non-linear development, that is, the number of branches that we are going to create is no limitation, because first you are going to create everything in your workspace, and Git, every workspace will have a copy of the repository, so you are free to create as much as you want, and then based on your requirement you can completely distribute it to any particular repository as a central repository, and all the operations is going to be very fast, because your workspace is going to contain a copy of the repository, and anything that you do inside it is what you're going to store first, and then you're going to pretty much move it on to the central repository, or you can take from the central repository and update to your workspace. That's the advantage, where when you compare, especially with a tool like Subversion, which is also an open source tool, now Git has this advantage majorly. Okay, so faster commands or the performance, and then a distributed approach, because everything that you do is going to be stored in your repository, and you have a reference where you want to share it with anyone else. You choose what to share specifically and then put it, and then branching, you can create as many branches and keep merging, so that everything is first done in your workspace, not directly on the central workspace. So that's the advantages why in the concept of DevOps, it's quite easy for the developers or the users to do their day-to-day activity, as well as lesser maintenance effort, as well as it's easy to set up a process as a product which you want to work on. Okay, so by this, we'll be completing the first module. And from the next session, we'll be talking about the next module called build management, where we will first see what is build management, and then why do we need it, and then we'll try to understand the concepts of build, and then we will use a tool called Maven, using which how you are going to work on this. We'll be going through one by one. Okay, so I'll stop the class here.